Hello, everyone. Welcome to Duke's Finding I&I webinar. We appreciate you being here today. I am the marketing coordinator at Duke's, and I am honored to introduce our speaker, Mike Ping. Mike is the technical manager at Duke's and has over 23 years of extensive experience in the wastewater industry. He's a licensed professional engineer in North and South Carolina and a graduate from Clemson University with a degree in electrical engineering. At the end of the webinar, we encourage you to use the Zoom chat feature if you have any questions. And then if time permits, we will be providing you with the opportunity to raise your hands. I will unmute you and then you can ask your question. All right, thank you once again for joining us, and please join me in welcoming Mike Ping.
Thank you, Caitlin. Can you hear me okay?
Yes.
Good? Okay, very good. I'm not at my normal office here, so let me get my screens going. Yeah, so again, I'm Mike Ping, and I'm the National Technical Manager here at Duke's, and this webinar is focused on finding I&I and optimizing and utilizing multiple data sources. Yeah, so to touch on Duke's and kind of the wheelhouse, I like to say for Duke's and what we do here, we're going to focus in on the kind of the green square there, or rectangle, I should say. But as a whole, this is what Duke's does. Duke's is known for chemical root control. Duke's, we do lots of SSES work, a lot of TV clean kind of work, multi-sensor pipe inspection. We have a new technology out that we'll probably do a webinar soon. It's a drone inspection on large diameter pipes, both storm and sanitary. We get involved with hydro excavation, and in the western part of the U.S. do spot repairs and sectional lining. So looking at a sanitary collection system and all the monitoring possibilities that are out there, it's important. And this kind of approach to this presentation here really gets into and involves budgeting. So it's important to recognize that each data set has its own cost structure. And I'm sure there are people that have been around flow monitoring and would know firsthand about that. But certainly some of these data sets cost a lot more than others. And of course, it's great to spin up a project that's an ideal scenario, but quite often, I get involved with projects from coast to coast, and most times the limiting factor on the project and the idea and the scope and all that, of course, it's budget related. So, when we talk about optimizing these data sets and optimizing the approach, I mean, the budget is certainly part of it, right? So, each of these data sets and the three here that we're speaking about today, flow monitoring, we'll get into the details, micro detection, the word micro detection for us and for this presentation is referring to level only measurement out in a gravity collection system. And then certainly, pump station data can and does play into it. But, flow monitoring is not inexpensive data. So I've got kind of $4 signs there, right? And, micro detection, the level only technology that's really gaining steam kind of in our industry as a whole, it's a lot less. It's a fraction of it, in fact, right? And then when you think about pump station data, there's several approaches. We're going to talk about one here that's kind of the $1 sign, but when you get into SCADA and so forth, it can go way on up, super sophisticated controls and so forth. So what we're trying to talk about here is the possibilities to blend these datas, kind of minimize the budget, maximize the data. So just to make sure we're not leaving anybody in the dust here, just a snippet on kind of I&I inflow and infiltration. What we're talking about here is any kind of extraneous storm water, rainwater making its way into the sanitary collection system, kind of represented by that middle photo, which ultimately makes its way to a biological wastewater treatment plant, which biologically cleans the water, and then it makes its way down to the sanitary sewer system. So um, hopefully that water doesn't get piped up, but it's always interesting. I like to kind of run through this each time here, uh, what those impacts can potentially be and putting actual numbers to it. Now, this is probably a pretty extreme example, but let's say that 2 acres along this road right here in the top left is ultimately funneled to a drain that's making its way to the sanitary collection system, and there's a 1 inch rain event, right? So just simple length times width times height, translate that into gallons, it's about 50,000 gallons, right? But rainfall isn't evenly distributed, so if that 50,000 gallons falls within, let's say, 3 hours, right? We're talking about 17,000 gallons per hour. We're talking about, translating that into gallons per minute at 278. And it's roughly 2,000 plus homes. It's roughly, a little bit less than a half MGD. And if were to look this up, right, an 8 inch full pipe flowing at 1 foot per second, right, translates into a flow rate, instantaneous flow rate of 156 gallons per minute, much less than the I&I. So this, and again, I realize it's an extreme case here, but or example, but it's very easy to overwhelm the collection system with inflow and so forth. I just saw, as kind of a side bit, this past week, I've been in the collection, flow monitoring world for over 20 years, and I saw a flow monitor that had a data set that had a peaking factor of 190, and couldn't believe it, right? So it's straight up, right? So obviously that utility has an inflow source. I thought that was interesting. So when we talk about those three circles, right, the one of the big ones is flow monitoring. So flow monitoring has been around for over 20 years now. It's kind of late 90s is when this hardware was being developed, and it's certainly become like an industry established method to provide some assessment out in the collection system. But this is kind of what it looks like. This diagram here on the right. You have a logger of some sort. It's kind of the cylinder shape. It's kind of the brains of the unit, a cable, and what's shown there is what's referred to as a submerged area velocity sensor. So, we own a bunch of the equipment here on the left here. That's the Hach brand, HACH brand equipment. There are other brands out there. There's probably the biggest brand would be ADS. And there's another brand, ISCO, and those are kind of the three major brands of hardware that are out there. And each kind of has their own pluses and minuses, but this equipment has evolved greatly in the past 25 years. So terminology, I hear this all the time, open channel, area velocity, these are all the same thing. So just to get us on the same stage here, open channel, area velocity, that's the kind of the mathematics behind it. We're in the gravity system, and a lot of people, refer to it as traditional flow monitoring. So we need to touch on just how this works, right? So it's important because we're going to talk about level only and kind of the differences. So this, in the case of, a full area velocity flow monitor, there's a pipe. The fluid is conveyed, but happens because of the gravity situation. The pope is on, or the pipe, not the pope, is on some sort of a slope there. And so there's two things being measured: the velocity, which is represented in this equation over here with the V, and then the area. The area stems from the level measurement. So the direct measurements that are happening is there's a direct independent measurement on the front part of the sensor that measures velocity. And then there's different technologies, but a very common one is a pressure transducer that's somewhere on the bottom of this sensor that is measuring the level. And then the logger does the mathematics to convert that level into a cross-sectional area that's dependent upon the pipe diameter. And then just kind of running through the basic math, the flow rate, area could be in square inches and multiplied times a velocity of any kind of unit, but inches per second. And that, what you end up with is a volume per units of time or gallons per minute or something along those lines. But that's in essence, that's what flow monitoring is. And the other piece of flow monitoring is most of this hardware is the I would say all of the hardware platforms available in the marketplace now for flow monitoring. There's a cellular telemetry piece where there's an antenna and it's transmitting data on pre-programmed intervals that could be every 15 minutes all the way to every 24 hours or something like that. Speaking for us, we do lots of flow monitoring. We quite often program these devices to call out and dump data every 3 hours, right? So if you call more frequently, then the batteries die sooner, and if you want it to last longer, then you call out less often. Here are some pictures of kind of what it looks like. If you haven't seen it, it's a very busy site. There's lots going on. Again, I've been around many flow meter installations, and even these days I go out, it's always surprising how many parts, pieces. You have a blower in this picture. There's safety. There's the road. The manhole could be in the road with traffic control. There's a generator to do work and so forth. And then, this hardware set over here on the left, that stuff is known to be temperamental, right? It's not you open the box and hit a few buttons and it wakes up and calls like an iPhone. It takes expertise and so forth. The conclusion here, it's a very busy scene with very specialized knowledge and so forth. So one may ask, hey, since it's possible to get the actual volumetric flow rate with a direct measurement, why not just install flow meters, quote, kind of all over the place, right? That, and the reason is the relative high cost, right? So if you have not been around a flow meter project, if the pricing can range very quantity sensitive, location sensitive. The street would cost more than often some, in the front yard of a residential area. But, those numbers can range from, $1,500 per site per month up to, it could be higher, but I would say like $3,500 per site per month would kind of be on the high end. But again, that's not to quote anything. It's just to kind of give some perspective on it. It's not cheap data. When you talk about a 6-month or 12-month project and you have 10 meters, 50 meters or whatever, that number adds up very quickly. Okay. So what if it was possible to get 80-ish% of the value of that flow data with only 20-ish% of the cost, right? A small fraction of the cost, probably would be pretty attractive. And that's kind of what's been going on. I go to lots of conferences, WEF collections, and then state conferences around. I see more and more of like level only being introduced into collection system assessment. It's I like to think it's a growing alternative, right? Or what we're talking about here, not necessarily alternative, but like a combination, right, to optimize and so forth. So for us, we own at Duke's many thousands of these things. We offer a service called micro detection where we do this on its own. And the intent, that's kind of what it looks like, those pictures. But, the intent is to locate and quantify I&I in a sense of kind of over here, not over there, kind of the number one there. These level only meters, we quite often place them 1,000, 1,200 feet, that dense. And that you can see that picture there on the left there, that diagram, each of those squares is a level only measurement point. So you can see high density. If that were a flow project, there's probably one flow meter at the bottom of that area, right? So it's a little bit, it's some different, kind of the same principle where you're comparing wet weather patterns to dry weather patterns, but it's a little bit limited in the nature of the data. But there's a lot more data, and there's an allowance for that because the cost structure is very different, right? So in our case, level only, there's no telemetry built in. So it's just a very basic measurement, right? With the idea of, hey, let's collect data and see where things are reacting and where they are not reacting. We do provide a volumetric estimate. Here are two graphs of what this can look like. These are real graphs from a previous deliverable, and looking at the graph on the right, the red is the level, just basic level. You can see it's kind of between 0 and 1 inches there. It's kind of hard to see. It's pretty small there. And the blue curves are that's the rain data presented in a 24-hour increment, kind of midnight to midnight. So if you look closely, you can see the largest one on the graph on the right is almost a 3-inch rain event, during a 24-hour span, and a couple that are right about 2 inches, right? So significant rain events, no difference in level, hence the basic conclusion of, there's very little to no reaction to the rain event. Now, on the left, kind of the top left there, kind of the traditional signature of I&I. Rain event, it's the same rain event. It's in the same study around the corner. And the classic signature of an increase in level, right? And it dwindles out over a period of time, and another rain event, and it comes back down, and so on and so forth. Now, on that one, you see an additional data set presented, the gallons per minute, the instantaneous flow rate. When we do level only, we present that as an estimated flow rate. Now, I'll say that that's kind of with an asterisk. So, when you get the project 2 and 300, it's a lot of progress has been made compared with before. So it's a good estimate, but it's not to be used for billing purposes or even like modeling purposes, nothing like that. So where these came from, you can see here on this diagram on the left, and kind of the same residential area. One area reacted, one did not. Therefore, future resources, future efforts, limited efforts, limited budgets can be really focused in on a problem area that has a known data set, can be presented, and so forth. So we present these results in a dynamic deliverables platform called Insight 360. We present all of our data with this, and so it's a dynamic platform where you can click, and the graphs pop up and all the data is presented. And yeah, you can see here, there are flow rates, volumes presented, and it's all in a nice table with the problem children, so to speak, are kind of shuffled up to the top of the area, and it's very easy to digest and so forth. So to kind of conclude, kind of level only, we get into this where it's kind of how are the volumes kind of aggregated as you flow downstream, and in this kind of example here from left to right. So if going from left to right, if there's a manhole, the black dot, and there's a total estimated increase of 50,000 gallons from dry weather to wet weather, that may show up as red. It's a big increase, right? Then the next manhole, or maybe a couple manholes down, let's say, if it has that same increase, well, there's no net increase, right? So a smaller reaction, and that would show up as green, and so on and so forth. A moderately large reaction, a minor reaction, kind of as you work left to right, and so on and so forth. So whoops, clicked the wrong button. So here's a question to think about. For the purposes of locating I&I, how much does it really matter if these values, these estimates, are off by even 20%, right? Now that's a big number. I realize that, but let's say 10, 20%. If it's off, look, it's not critical to the equation, right? Hang on here. I'm having a computer issue. Bear with me just a second. Okay. Yeah. If these values are off some, for locating and quantifying I&I, there's certainly a logical argument that could be made. Like if that plus 50,000 is plus 60, it's still red, right? So that's the point being made here. And then, to kind of sum this up and kind of get going in the direction for this presentation of optimizing, what if you start to think like, hey, let's combine and optimize these data sources. And let's take that same series or that same basin or whatever it is and add a direct flow measurement at the bottom of it. Or if it's a much bigger area, strategically add direct flow measurement at certain points, right? Now we've talked about that the flow data, the area velocity flow data cost is much higher, and these estimates here are much lower in cost. So there's a way, and kind of the direction we're going here is there's a way to optimize and blend that to really hone in and meet kind of whatever the objective is, right? Now, if it's again, a billing situation, or it's a very intense hydraulic model where, you know, direct measurements are needed, obviously there's going to be more flow measurement or all flow measurement, but it may be geared up a little bit towards, hey, let's understand where the I&I is coming from, where it could kind of be geared the other way. So there's no like right or wrong ratio, I would say. It's more about, hey, combine these tools to produce whatever the intended results are or goals. So here we have a measured flow value, and we further isolate into the smaller areas. So to toss it, I kind of mentioned this earlier, here at Dukes, we've had many hundreds of level only, again, we call that micro detection, many hundreds of projects with many, many thousands of sites. So lots of experience. And it's, for me, kind of coming out of the flow meter world, in the kind of the early 2000s, it's really come a long ways. And I think the idea of measuring level only 20 years ago would have been, not accepted, right? And it's certainly gaining acceptance. I've seen many presentations in the past months at different conferences by various engineering consultants. So here's an example to kind of show, what a combination can look like. So this is a 1 million foot area. If you look closely on the map there, you'll see a bunch of yellow stars. There are 30 of them. Those are represented, those are flow monitoring sites. So that's the more expensive data. This project, like many, or like all project, there's a designated budget, right? So the way it broke out here was just between the utility and my group of colleagues. Hey, let's do 30 flow monitors to get that direct measurement, and then it's augmented by 170 level only. So there's a lot of data coming out of this, and it's having 200 data points in this million foot basin area, is a pretty strong value proposition. With the general idea being like, and it's kind of hard to see, but that bigger red square there's just trying to show, like, there's one flow monitor right in these areas, and then within that area, on average, there's 6 or 7 level only measurements happening, right? And usually the reactions aren't evenly distributed. So, theoretically, we can wind it down into potentially 5,000 foot. Now, there's no magic number there. That could be 1,000 foot. We do lots of them that are 1,500 feet, right? It could be 10,000. At the end of the day, that's dependent upon the budget. Right. So, typically what's next is follow up SSES here. And there's, I&I is going to be found. Hey, Caitlin, I got a problem here. I need everybody on this call, just please bear with me here for about 30 or 60 seconds here. Sorry, I'm not at my home office.
What can I help you with, Mike?
Yeah, I'm all right. I got stuff popping up, and I'm not at my. I'm okay here. Hang on, I'm back.
Okay.
Sorry for that, guys. Cancel. Bear with me here. My share thing is, something's happening here. Just sorry here. I'm gonna.
Mike, do you want me to pull the presentation up and share it?
No, just bear with me. Just 30 seconds here. Sorry. Yeah, I think I have it here. Yeah, it's sorry. Stop sharing. Share. I hate this. Sorry, everybody. Okay, I think I'm on the right track. Yeah, sorry for that. I think I'm back here. Okay, apologies. Okay.
We can see it. We can
Yeah,
still
you
see
can see it
it.
good. That's important. All right. Note to self: be at the home office when you present. Yeah, so tracking these down into 5,000-foot increments, and obviously, kind of the next steps would be kind of the standard SSES stuff that could be, maybe TV, maybe smoke testing, the kind of the standard SSES, right? So, it's kind of a phased approach here, and doing this upfront work can theoretically allow for a focused effort to for these more costly next steps. So, kind of the next iteration of this is like to think about, what if a system is influenced somewhat all the way to dominated by pump or lift stations? So, if you're a consultant here on this call, I would ask this. I mean, how many times have you worked with somebody and there's some sort of collection system assessment going on, and the question pops up like, "Hey, can you send over the data for a pump or lift station?" Right, even one of them, right? Quite often that data could exist somewhere. Maybe it doesn't exist. There's all types of scenarios, but like, that's where this third piece of pump data it comes in. So when you look at a pump station, right? I've got my flow meter over there on the left, right? It's possible to measure the flow directly with the open channel area velocity meter, just on the influence side of the pump station. Now, sometimes it's that's undesirable. The wet well level, kind of, you can see my on off where the floats would be. Quite often the wet wells are allowed to fill up to the point where the pipe is essentially backing up every single pump cycle, right? And then the pumps turn on, and basically you get a situation where the flow meter is recording flow where it's like moving fast, and then the pumps turn off, and it's filling up, and the velocity is very low, and it may go all the way to where the velocity is zero, right? So if there's multiple pipes coming in a wet well, the velocity could theoretically go back, could be negative, right? So it's not an ideal. That could be a long technical kind of conversation there, but the open channel flow meters do not like these transient conditions, right? And if you think about like, well, look, let's measure flow on the discharge side over on the right, and if that red arrow kind of goes over the hill where the collection system turns back into gravity, it's not ideal. And I pulled up a data set that shows what that can look like, right? So this is a recent, this is very current data here. And you can see each day, you see kind of the pause in the middle of the night where the pumps are, mostly not on, right? Very, very low flow rates. In fact, those flow rates could be so low where the velocity is too low to even really get a good measurement, or it could be that the level is too low, or both. The open channel equipment likes to have good velocity, good level in order to get good quality. And then you see during the day, radical changes, right? The pumps turn on, and there's basically a slug of water kind of coming over the hill on the discharge side. This hardware is built to wake up every 5 minutes, record a snapshot, and then go back to sleep for 4.5 minutes or whatever, right? It's just not built for that. Now, can it be done? It can. It just needs to be understood that the data, the more transient conditions that are happening, the shakier the data looks, right? So it's just not ideal. So if you have this system that's influenced by lift or pump stations, what should the approach be? Now, this is a pretty extreme scenario here where there's about 100 pumps there kind of on that peninsula, but like, that this particular map where it came from, the phone call came to me, hey, we want to we want flow meters out. And look, that they're not going to work very well, right? Because of what we just talked about. So then it's like, do we use existing pump station data? And we get into the conversation where how often is the pump station data just one click away? I mean, usually from my personal experience, it's almost never, right? It's hard to get. IT could be involved. The pump station group maybe is a different group than the maybe an engineering group inside of utility, right? There's lots of hurdles. It could be that the data is collected on only monthly intervals, right? Or weekly intervals or even daily intervals. To do a wet weather analysis, that data would need to be in preferably every time the pumps turn on down to 1 second or something like that, right? Um, the data could exist on someone's laptop in what I like to call a Frankenstein Excel file, and it's all too common. And look, a lot of them are excellent. A lot of these home built Excel files are super good, but they don't serve the utility well, and that like only one person or a select group can view it, and then only probably a smaller group understand it. So to address this need, this is something that we're doing here inside of Dukes to augment those other two circles. So we're still talking about pump data, right? This is a data collection that is low cost. So we talked about flow monitoring being kind of the high end data collection for flow out in the gravity system, and then level only being that low cost. What we're talking about here with P tracker and pump data, this is the low cost that can help a utility with 100, 200, 500 pump stations, or if it's just a small station and there's no existing data and it needs to be brought into this I&I or capacity assessment project, right? So this Dukes P tracker, is where an existing need is to locate and quantify I&I, and interest to understand the pump station capacities, wet weather, dry weather, that analysis piece, potentially a high concentration of pump flows, too many. I mean, I talked to one utility that had over 700. I mean, they're not going to have full skate on all of that. It's just cost prohibitive. A need for straightforward and practical I&I information at a very low cost. We target these webinars to be 30 minutes. I'm going to go just a tad over, but we're not going to go on for too much longer here, just to check in on the time there. Yeah, so this is what it looks like here. So it's kind of hard to see, very inconspicuous data loggers there over on the left. Yeah, it's inside the panel. Yeah, this, most utilities are pretty sensitive towards pump station panels. Look, we're picking up the runtime. We're doing a drawdown to get the estimated flow rate and provide this estimate level of information, but very, very small impact on day-to-day operations. There's no impact going on. It's not intrusive. There's no drilling. There's none of that going on. It's a quick and easy installation, which translates into low cost, right? So potentially lots of data to augment a study, at a low cost, right? And then the analysis piece, and I realize you can't see everything, but at the end of because it's small, but at the end of the day, we're talking about comparing pump station stresses, wet weather versus dry weather, those ratios, and then, how often the pumps are running, the volumes associated with that, the capacity during dry weather, capacity during wet weather, and so forth. And then, operating these things, because of the ease of installation and swapping out, would be, a swap on a defined interval. We're kind of starting out at the point of like doing it every 2 months, right? So it's just collecting data. Somebody goes out there, unplugs it, plugs a new one in, takes 30 seconds. So again, very low cost, but then like spinning out a report that's practical, kind of easy to digest, on the utility side for sure, but still providing some good technical content for like high end, analysis that the engineering community often is interested in. So with that, yeah, I mean, we've talked about these three, and hopefully you've gained something and some perspective. I mean, there's lots of flow monitoring going on in the marketplace. There's a growing amount of level only, and then the pump station data that varies from one end of the spectrum completely to the other. So for anywhere from no data whatsoever to fancy high end like NASA, like SCADA. So hopefully what you've gained from this is like, there's ways and means, and this is the current approach at Dukes, is to uh, get presented with a potential I&I or capacity or study of a collection system, and apply the right tools to optimize, so that the most can be gained with the least amount of budget. So thank you for the patience. Sorry for the blip there in the middle. That's all we have. I think, Caitlin, do you want to touch on how we can ask questions in the chat, or you can unmute and so forth?
Yeah. So we have the chat available for questions as well as Q&A. We did have some questions come in throughout the presentation, Mike.
Okay.
So I can go ahead and read some of those off. One of the first ones was, I wonder if your method involves any model calibration, or is it completely data driven based on level sensor measurements? I apologize.
Yeah. So I think I think I know where that's headed. So our position in the marketplace is that we work to support people that are doing models. Like, we do not offer hydraulic modeling services like at all. So we're data producers, and we're trying to optimize. And ultimately, I mean, our target list of clients would be people that are offering hydraulic modeling services. So you know, the I think the another comment on that would be like, my experience has been that everybody kind of has their own approach to it, and some would accept the level data and utilize it, some would not, right? But the pump data, kind of the same thing. So hopefully that answers it, and if it doesn't, then maybe you can add to the chat. Hopefully that's a good answer. Caitlin, you still there?
Just talking on mute, pulling a Bob. The next question that we have is, how much I&I is considered normal versus excessive?
Yeah, that's a good question. So I can only answer from my own personal experience, and now that so most of my career has been kind of in the Mid-Atlantic region, Carolinas, Tennessee, Georgia, Virginia, where a peaking factor, a multiple of of increased flow would be 5 or even 10 is not terribly uncommon. Like, and I'm talking volume at the wastewater treatment plant, right? Could be up in a pipe segment too, but sometimes these days we're I'm involved on projects that are in the West, and sometimes it could be alarming if the flow increases by only 50%, so not even 2x, right? Um, so it varies region to region, definitely. But I think, just generally speaking, a peaking factor, a multiple where people start their, on average, their antennas going up would be, 3, 4, 5 is starting to get there. But look, I saw one early this week where it was, I think, close to 20, like the wastewater treatment plant. So, you know, that's kind of the range.
The next question we have is, which areas of our collection system should we investigate first?
Okay, so if yeah, so assuming somebody or utility is kind of starting from scratch, we typically do, we can go down. Usually, it's budget dependent, and it's kind of dependent upon can they do like do a more comprehensive single phase approach, or if the project is such that it needs to be budgeted over a couple of fiscal cycles. So there's kind of a one phase versus two phase. If it's one phase, we may do, flow meters every 20, 30, 40,000 feet of pipe and then add the level only and do all of that in one phase, kind of like that example. That's the one that I did with the million feet. That's a single phase project. We're in there, we're going to be there for 3 or 4 months. It's out, the results are cranked out, and that's the end of it. It's also very common to do a two phase where there's flow monitoring. This is very common. Maybe we have those 30 meters, like in that million-foot example. We don't do any level only, and we wait to get the results, have a discussion, uh, consultant, utility, us, and then maybe the additional steps are only applied in the areas where the flow meters had the biggest reaction, and it's the biggest concern for the consultant and for the utility. So there's, in my opinion, there's no like right or wrong on that. It's just kind of like, do you want to get all the results in one shot, or do you want to do a multiple phase? But I would start, you start at the plant and work your way out kind of on the interceptor lines and try to just whittle it down into the smallest area that you can. Ultimately is the general approach.
Okay, and then how frequently should flow monitoring be monitored or flow monitoring be repeated?
Yeah, so again, so that's similar to the other answers. It varies drastically utility to utility. I know utilities that have meters effectively, they're pretty much permanent, right? So, I can think of a utility that's in a city that's maybe two or 300,000 people size city, and they may have 50 meters in at all times, right? Now they may have out of the 50, 10 that get moved every 6 months to kind of focus in. But the idea is that they're monitoring for I&I proactively. So, sewer system is not static, it's dynamic. You can do a study now and it could change completely 1 month later on, right? So but it goes to the other end where there are lots of utilities that have never done flow monitoring. So probably the average would be to do a study of some sort. I would say every 5 years or something like that, just to make sure that you're keeping a handle on it. Another way to look at it for me is, you know, wastewater treatment plants are mandated to have flow monitoring on the influent part of the plant, right? They have to know what the plant flow is for themselves and to report it, right? So, depending on a utility's map, you have one permanent meter there, right, at the plant. It may be a good idea to go out, get the interceptor where there are major branches coming in, and just bump it up to 3 or 4 with the idea of you can break up the whole system into 4, 3, 4, 5, whatever budget can be stomached, and like at least you can break that down. So if when I or flows change, it's caught as it's happening. So I don't think there's like a right wrong answer on that. I think it's that would kind of represent the middle.
All right. Our next question is, how does Insight 360 integrate and analyze data from multiple sources, such as flow monitors, rainfall gauges, and SCADA systems? More specifically, if a utility already has flow monitors from another manufacturer, can that existing data be imported into Insight 360 and analyzed alongside Duke's micro detection data?
Yeah, so I understand the question there. So Insight 360 is a tool to present deliverables, and it's not a tool that's like an analysis tool. It's completely just it's on the back end, so that's not a live like dynamic platform. It's like we do a study like smoke testing or TV. We load it all up at the end, and it's part of kind of the reporting procedure. So it's you can see the rainfall. We typically do not integrate both level and flow at the same time. However, we're in the midst of evaluating that and like building something that can do exactly what you just talked about. So we're building it in a way that we want to be able to accept any kind of flow data and any kind of level data, present it all together on one page, look at scatter plots, look at Manning's equation curves, and throw all that stuff on one chart if need be. But that, we're not there yet. And my hunch is that we would be a couple of months out. So right now we utilize on the flow side the manufacturer's website. So that snippet we saw was the Hawk brand. It's called FS Data. We utilize that to look at data, and then for the analysis, we bring it inside and just crank that out. A lot of times in Excel. So that's kind of where we are as a whole.
And then I think the last question that we have so far is, are after the identified defects are repaired, what measurable reductions in peak weather, wet weather flow, rainfall, derived INI, or total flow were achieved?
I got most of that, Caitlin, but if you can just reread that, if you don't mind.
Yep. So in the beginning of the question, they had asked for some case studies comparing flow analysis and predicted INI sources. But then in the latter part of the question, they asked if after the identified effects were repaired, what were the measurable reductions in peak wet weather flow, rainfall derived INI, or total flow were achieved?
Yeah, so I don't like in this presentation, I don't look to be honest, like we do a lot of the front end. Most of our projects historically have been on the front end. Sometimes we do like post rehab monitoring. So I've been exposed to that, but like our position is we're never like the consultant. So quite often we don't. I would love to get all that information on every project, but like we, to be honest, don't get it. But I can think of one that was really noteworthy. We did a level only project in a pretty substantial city, and we were not told that it was a post rehab project. And during our project period, there was an 8-inch rain event. All right, in 24 hours. Right, humongous rain. Um, and so we're working through it. Turns out there was basically no INI. I mean, there was a tiny little bits of INI here and there, and so of course I'm apprehensive about the results of that being in an 8-inch rain event. But it turned out, they were forthcoming and saying it was post rehab, and that was their expectation. So yeah, so I guess that's just kind of an interesting side note, but I've seen another case of that. And then, I've seen other ones where there's work done and very little reduction. So I think like our position is we're more just on the measurement and providing of data. And we kind of fit in between the contractor world and the engineer world. And we try to do some baseline analysis and provide it for insight. I think hopefully that answers the question.
All right. That is all the questions that we have, unless
That's
anyone
it.
has any other questions. Thank you. I appreciate you answering all
Yeah,
those questions, Mike. Thank you.
of course. Whoever's still on, thank you for attending, and hopefully you got some out of it. And if we can help, just let us know.
All right. right, well, we will
All right.
give a few more seconds, but other than that, I think we are for any extra questions, but other than that, I think we're good.
All right. Appreciate it, Caitlin. Bye-bye.
Thank you, everyone. Bye.